Okay, so today we're going to be talking about systems of linear and quadratic equations, which is where you graph both a linear and a quadratic equation on the same coordinate plane, and you're finding where they intersect, or you're solving them by substitution. So there are three types of solutions that you can have to a system of linear and quadratic equations. Either your quadratic can intersect the line 2 times, it can intersect the line 1 time, or your quadratic and linear equation can never touch at all. Okay, so those are the three types of solutions that you're going to get. 2 solutions, 1 solution, or no solution. So those are the three situations that can occur. Now when it's 1 solution, that will occur at your vertex. So the first example we're going to look at, we're given a linear equation and a quadratic equation, and we're going to graph both. So to graph a linear equation, f of x is just the same thing as y. So the first thing you do is you look at your y-intercept, which is -1. So go ahead and plot -1. And then you're going to look at your slope. So what's the slope on the x right here? Yeah, 1 over 1, so we go up 1 over 1, up 1 over 1, and so on. And you can start to see a line forming, and once you get to that point where you see the line forming, you can go ahead and connect it. Like this. So that is f of x. So everybody with me on how to graph a linear equation. You look at the y-intercept, that's where you start, and then you go with your slope, which is 1 over 1, because there's an implied 1 here, up 1 over 1. If you're still not sure about graphing linear equations, I can recommend some resources for you, or some YouTube resources, because this you should be comfortable with at this point. So now how to graph the quadratic. So the easiest way to graph a quadratic is to find its vertex first. So how do we find the vertex? We have a formula for that, right? X equals negative b over 2a. That's the formula for the x-coordinate of the vertex. So we're going to use that formula to calculate the x-coordinate of the vertex. So x is equal to negative b, which becomes a positive b, over 2 times -1. This becomes, I'm lagging, this becomes x equals -1. Okay, so I'm going to zoom out here because I'm running out of room and I'm lagging really bad. We gotta wait a second because it's slow. So, once you find where the x-coordinate of the vertex is, you make a table. In the middle of your table is where you put the x-coordinate of your vertex. You guys remember this? And then what do I do with that x-coordinate of my vertex? Yeah, I gotta plug it into the equation. So g of -1 is equal to -1 squared minus 2 times -1 plus 3. G of -1 is equal to -1 plus 2 plus 3. This is 4, right? So that's how you find one point, which is your vertex. Now how do you find the rest of the table? Well, you just backtrack and forward track on the x. So what's 1 smaller than -1? Yep, -2, -3, and then this will be 0 and 1. So you can go ahead and plug all of these in to get values, or you can kind of skip around. So I'm going to plug in this one and this one so I can kind of see where it goes, and I won't have to do all that math. But like I said, you can go through and plug each one of these in if you really want a really good, concise graph. So I'm going to plug in -3 in for g of x. So g of -3 is equal to -3 squared minus 2 times -3 plus 3. That's g of -3 is equal to -9 plus 6 plus 3, which is -3 plus 3, which is 0. So this is 0. Now, what do you guys remember about quadratics? They're symmetric, right? So what's this value right here? 0. I don't even have to perform the substitution, but if you don't believe me, you can, and you can see that it will come out to be 0. So in theory, you could plug all of these in. So now that I have some of my table, I'm going to plot what I have so far, because this might be enough for me to get the information I need and save myself some of the time of doing the full thing. So -3, 0 is right here. -1, 4 is up here. And 1, 0 is right here. So if I connect this, so how many solutions do I have on this quadratic and linear system? Good. I have 2 solutions. And my solutions are 1, 0, and my other solution is -4, -5. So something that you probably are noticing, well, what if I drew my quadratic wrong and I landed on the wrong spot? So that's why graphing systems of equations is not the most precise way of getting a solution set. So we do this, and you have to be able to recognize, like if I give you a graph already drawn, you have to be able to recognize, oh, there's 2 solutions and you can find them. However, graphing to find solutions can be a little unprecise sometimes because it's kind of hard to make sure you're falling in the right spot sometimes when you sketch a graph. So for that reason, we use substitution method. So I'm going to skip all the way forward, and we can come back to some of these graphing ones, but I'm going to skip all the way to example 3. Yes? Oh yeah, sure. So I'm skipping all the way forward to example 3 because we can also use algebra to get the same results that we got before. So the first thing you want to do when you want to use algebra to find the solution to a system is you need to make sure that they're both in terms of y. So in this case, are there any y's in the equations at all? No, but we have something equivalent to a y, which is an f of x and a g of x. So anytime you have f of x, g of x, h of x, something of x, you can replace that with y. That's just another way of saying y. And this is a concept that we talked about a lot in geometry. Let me try to think. It's the transitive property. Yes. Okay. So if y is equal to all this stuff, this long trinomial, and y is equal to this, then that means this is also equal to this, right? Because they're both equal to the same thing. Does that make sense? They're both equal to y, which means that they must be equal to each other. So once you get them in terms of y, you're going to take whatever you have on the right side and set them equal to each other. So negative x squared minus 5x plus 6 is equal to x minus 1. So you're going to set them equal to each other once you get them in terms of y. So then from here, you're going to get everything to one side so that you can factor it. So I'm going to subtract over the x. That gives me negative x squared minus 6x plus 6 equals negative 1. And then what's my last step to get everything to one side? Add 1 to both sides. Good. And when I do that, I get negative x squared minus 6x plus 7 equals 0. So now we can factor this. Now, you have to make sure before you factor, unless you're using quadratic formula, of course, that your a term is 1. Is my a term 1 here? It's not 1, but it's negative 1. So what can I factor out of this to make it 1? Negative 1. So I'm going to factor out a negative 1. And that's just going to change the signs of everything. And now that I did that, I'm able to factor this into two binomials. So, what are some factors of negative 7 that get me to positive 6 when I add them together? Any ideas? 7 times what? 7 times negative 1. There we go. And now we use the zero product property, which states that the product of any things, any items, terms, binomials that are equal to 0, you can set each one of those equal to 0. And when we do that, we have two one-step equations that we can solve for x. This gives me x equals negative 7. And this gives me x equals 1. This one over here gets rejected because it's a non-solution. So we have two solutions so far. Well, we have two partial solutions. So my one solution is negative 7 comma something and x comma something. So in order to get the full solutions, we need to know the y-coordinates of those two x's that we just found. So does anybody have any idea of how we could do that? Well, let's think about what this looks like. So if we have two solutions, this means that my quadratic and my linear equation intersect twice. And they intersect at a certain point, and we know they intersect at negative 7 comma something and 1 comma something. So in reality, if I plug these x values into either one of these equations, I'm going to get the same output, right? Because they're intersecting at the same spot. They occur at the same spot. So what should I do with this x value? Yes? Yeah, I can plug it in. Good. Yeah, so which one's going to be easier to plug into? Which equation? G of x. So you can plug it into the quadratic if you want to. However, that's more work. So I'm plugging in to g of x, and this gives me negative 8. And then I'm going to do the same thing with the 1. So g of 1 equals 1 minus 1, which is 0. And if you wanted to check your work on like a test or a quiz, not a bad idea to also plug them into the quadratic to make sure they're the same. Any questions about that? So if you were to graph this system, you would see that these intersect at negative 7, negative 8, and 1, 0. And I'll show you actually on Desmos if I can get it up. So when you're taking a quiz, your quizzes are all at home this year, right? So it's a really good idea to have your Desmos open on your computer and graph everything. Put it into Desmos, okay? It's just really helpful to get a visual. And if you have a graphing calculator, that works too. But for those of you that don't have a graphing calculator, this is a free online graphing calculator, so everybody has access to it. So I'm just going to graph these, and I'm going to show you what that looks like. So when I graph these two, you'll notice that it intersects at 1, 0 and negative 7, negative 8. So that's what the graph looks like for when you get those two solutions. Any questions about that? Okay. So let's try, do you guys want me to do one more with you, or do you want to try one on your own now? You want me to do one more? Okay, I'll do this you try with you, and then I'll have you try the next one. And then you guys can try a graphing one too. So for any of the graphing ones, you can also do this as well. and set them equal to each other. So we want to make sure that they're both in terms of y or f of x, and they are. So you have to make sure of that first. So you have to get y by itself if it's not already by itself. So like for example, there is one on your homework like this, so I just want to tell you. Like say I have y minus 1 equals 5. How do I get y by itself? You add the 1 over it. Then you could set it equal to itself. Or set it equal to the other one. You have to make sure of that first, though. I just want to make sure you guys understand that. So they both have to be in terms of y or f of x or whatever function notation we're using. So I'm going to set both of these equal to each other. Let's do it the other way around this time. Let's do 3x plus 2 is equal to negative x squared plus 3x plus 2. So I set them equal to each other. And I'm actually going to add everything over to the left side. So I'm going to add the x squared over to the left. That gives me x squared plus 3x plus 2 equals 3x plus 2. I'm going to subtract 3x on both sides. And then I'm going to subtract 2 on both sides. And when I do that, I'm left with x squared equals 0. Everybody see how I got x squared equals 0? So when I get to this point, I just have to take the what of both sides? Square root of both sides. When you get a square root solution like this. So this is just x equals plus or minus 0. And negative 0 and positive 0 are the same thing, right? So my one solution, because they're both 0, so if you get two solutions in the end and they're both 0, that means you just have one solution. So it's 0, comma, and then how do I get the corresponding y coordinate? Plug it in. And that's just 2. Any questions about that? Alright, so on your notes, before you do your homework, I would like you guys to try, let's see. So I'd like you to try example 2 on your own, and you can use substitution or graphing or both on that one. So go ahead and try example 2 on your notes, and I will come around and help you once I get my attendance up, okay? Alright, so for the first question, the first thing I need to do is to get my y value by itself, okay? That's always the first thing you need to do if it's not already alone on its one side. So I'm just going to rewrite it down here. And then I'm going to add 2x on both sides. This gives me negative 1y equals 2x minus 2. I divide both sides by negative 1, which gives me y equals negative 2x plus 2. Did everybody get that point, to that point? Okay, good job. So now I'm going to graph that. So my y-intercept is 2, and my slope is negative 2. So I'm starting at 2, and then I'm rise over 1 going down 2 units and over 1 unit. So down 2 over 1. And then I'm just going to connect this. So that's what our line looks like. And then I'm going to graph my quadratic. So in order to graph my quadratic, well, there's a few things you can do with the quadratic right off the bat. Of course, you can find why can't I think right now? Your y-intercept is this. So I know it intersects the y-axis here. Okay, that's what I know so far about it based on this. If you didn't know that, that's fine. You don't have to know that if you forgot. You can just use a table. So before I use a table, I have to find the axis of symmetry, which is negative b over 2 times a, which comes out to be negative 8 over negative 4, which is positive 2. So I can make my table. And this is going to be 2 something. That's going to be 1, 0, 3, and 4. We plug 2 back into my equation. And that gives me negative 8 plus 16 minus 6, which is 8 minus 6, which is 2. So 2 is up here. Now we're going to plug in 1. I think it's going to be 0, but we'll do the math. So this becomes negative 2 plus 8 minus 6. This is 6 minus 6, which is 0, which means this is also 0. So here and here. And now we know that quadratics have symmetry across the axis of symmetry, right? So if I draw my axis of symmetry in, right here, I see that I have symmetry across this line here. So that means that this must also be a point on the graph. Everybody see how I was able to find that? Okay, so then I would connect this, and we would get our 2 solutions to be where they intersect, which appears to be at 1, 0, and at 4, 4, -6. Did you guys get that who did it algebraically? Yes? No? You want to see it algebraically as well? What's up? Bathroom, yeah. So doing this algebraically, we already have y equals 2x plus 2 that we found, and then we have f of x equals negative 2x squared plus 8x minus 6. So since they're both in terms of y now, we're just going to set them equal to each other. So this is going to be negative 2x plus 2 equals negative 2x squared plus 8x minus 6. I'm going to add 2x on both sides. That leaves me with 2 equals negative 2x squared plus 10x minus 6. And then I'm going to subtract 2 over here, which leaves me with 0 equals negative 2x squared plus 10x minus 8. So now I can probably factor this, but I need to factor out a GCF here, and what is that? Two, but we're going to factor out a negative 2, which changes the signs of everything. So everything becomes opposite sign when you factor out or divide by a negative 2. So now I'm looking for factors of 4 that add up to a negative 5. Any ideas? Negative 4 times negative 1 is what? Negative. It's a positive 4, but it adds up to a negative 5, right? So negative 1 and negative 4. And that gives me x equals 1 and x equals 4. This is a non-solution. And that's how you would do it algebraically. And then what you would do from there is you would plug each of these x values back into y. So like for example, I would plug in y equals negative 2x. Well, now it's going to be 1. Plus 2. I'm just picking one of the original equations to plug in. That gives me y equals negative 2 plus 2, which is 0, which is what we got here. And then you would do the same thing for the 4. You would plug that in as well. And you would see that you would get negative 6.